All right, it's 11 o'clock. AC, you ready to go?
I am ready. Do you want
Awesome.
to say anything? You want to introduce John, and then I'll do the status.
Yeah, hi everybody. Well, this is the LSR working group, and this is Christian Hops, and AC's with me. I don't know if Alvaro's in, but John is here, and on Wednesday he'll be our new AD. And we have a minute taker, and John's said he can do the JabberScribe duties that are pretty minimal now with the virtual setup, at least. I think that's it. We have a pretty full schedule. We don't have an agenda, do we? Huh. We don't have an agenda slide, do we, AC? I don't think.
No, we don't. I didn't put that in there. Oh, well.
You can see that in the Cody MD.
Yeah, I got it up on a different screen. I mean, basically.
I'll share it. Hang on. I can just share the Cody MD. So, the mirrors and mirrors view. So here's our agenda. Does anybody have any bashing to do on this agenda? Any changes? We did make a slight change. I don't know if people noticed, but we moved bandwidth constraints to the third slot instead of in between the VTN and the L2 bundles. Okay. Well, with that, I think we're ready to go. So let me pull back the other slides.
I'm going to go quick to try and only stop when there's notable things. Next slide. Here's the note well. I'm sure you've seen it in other IETF meetings. The gist of it is, if you know about any IPR related to your participation in the IETF, whether it be in a meeting, mailing list, or whatever, you are obligated to disclose that IPR. Next slide. We didn't have any RFCs published since the last meeting. Next slide. Oh, I think I missed. Did you miss one? No, you didn't miss one. Oh, the Yang models. Yeah, I tracked down the Yang models. Thanks, John, for help out on the tunnel end cap and getting that through. So the top draft, the tunnel encapsulations, router information draft, will be published along with the tunnel end caps draft. But on the Yang models, I tracked that down, and it's a reference. What's blocking us is a reference in BFD to the TEAS Yang model. Now, the TEAS Yang model, I wanted to see how much that brought in. That also brings in the RSVP TE Yang model. So maybe if we can't resolve this, we might ask the BFD people to separate the MPLS module into a different draft, because it has a number of modules in the model, and that one could be in a different draft. We'll see how long this draws out, and we'll discuss this outside of this meeting. Next slide. This hasn't changed. I don't think anybody's really waiting for these drafts. I know some people have implemented it, but this entropy signaling. Next slide. Okay, there's some notable things here. First of all, on the SRB6 ISIS draft, Alvaro had comments, and we need a revised ID. So it'd be good if the authors could attend to that. The RFC 5316 BIS draft is just some protocol maintenance. It went from working group document to last call rather quickly because it's just removing the restriction that you can't use an IP6 only network. And prefix originator, I know who's got the pen in that. We also got to satisfy, have a revised ID for Alvaro's comments. The next slide.
I'll just throw out there quick the RFC 5316 bis is a dual working group last call, but the primary comments are running in our working group.
Oh, right. Thanks. Yep. Yeah, as always happens with a biz document, you get comments outside of cleanup comments outside of what the document was rewritten to remedy, and we're taking at least for the editorial ones, the authors are taking care of those as well. These ones we're waiting for. The first one, arithmetic, waiting for AD review. Flexible algorithm, that's going to be covered today. We're going to probably do another. We're definitely going to do another working group last call. Next slide. Okay, these are the drafts that we believe are ready for working group last call. A lot of Yang models. The PCE offers. I'll take another look at that one, see what I think about whether that's ready for working group last call. Next slide. Dynamic flooding. This has been around for a while, hasn't been any changes. I know there's been a lot of discussion. I think there's some implementations proceeding. We could discuss. It'd be nice if the offers would tell the offers can tell us if they think it's ready for working group last call. I know there are other documents that are dependent on this one, and there are implementations, so it's a high priority. Now, the draft below is probably the highest priority. The OSPF extensions for SRv6 for a number of reasons. Number one, oh yeah.
Go ahead.
You
song that?
Very brief question. Can you hear me clearly?
Yes.
Yes.
I noticed that in some of the status is noted as others believe ready for working group last call. It means that there is no working group consensus yet, or it is ready.
Well, the consensus will be determined during the working group last call, but the authors believe it. It means either Chris or I have to. Well, Chris probably, because I'm an author on a couple of those.
Okay.
Would have to do the working group last call and IPR, another IPR call.
Okay.
I mean, also throwing this slide up there is a way of letting people know that the authors believe that, right? And if somebody believes it's not ready, they could comment based on this. Okay, Tony is in the queue. Go ahead, Tony.
I got him. Yeah. I was just waiting for.
Just status, flood detection is implemented, no interoperability has been done yet.
Did you catch that? I didn't.
I think he said that they've implemented it. Is that right, Tony?
Yeah, correct. I'm fighting here with an iPad microphone. It's implemented, no interoperability testing yet.
Okay, implemented, but no interoperability testing yet.
Correct.
Okay, great.
Okay, go to the next slide. Now this next one, the OSPF v3 extensions for SRv6, I think this, hopefully we can get some priority on this because for one, there's a normative reference to it in the flex algorithm draft. And number two, Alvaro, when he did the ISIS, he said, okay, where's the OSPF? And I agree, it would be, you know, from a efficiency standpoint, would be better to get them done simultaneously, or at least close to one another, so it's fresh in everybody's mind. Let's see. I don't think there's anything else that we need to talk about on this one. Next one. Slide, please. Yeah, a lot of these are protocol maintenance. The first two are protocol maintenance that are in ISIS and not in OSPF. I think there's higher priorities, but we need to working group last call when we can. Next slide. Okay, we had a few new working group documents. The second one, IP flexible and algorithms, generated a lot of discussion. Hopefully that'll proceed. The tags draft sort, this is somewhat of a protocol maintenance that we never had anything more than tags for external routes in OSPF until we got to TLV based. And this is going back and allowing tags for non-external routes, just like we do for external routes in OSPF, just like we do for ISIS. Next slide. These are adoption. People have requested adoption calls, and we think it's reasonable, at least somewhat reasonable. We have the flooding speed. I think we'll have more discussion on that in the next. There's actually been some discussion between the chairs and the authors, and I think there's work going on both for this one and the transmit-based one. There's testing work going on, so I imagine there'll be some. I'd hope there'd be some discussion on that on the list, and some new testing results as well.
I have a comment on this, but Chris Bowers in the queue. Go ahead, Chris.
Hi, can you hear me okay?
Yes.
Yep.
Okay. Could you go back a couple slides to the dense flooding and dense graphs? Yeah, so I guess, was Alvaro suggesting that, so to the comment that we should possibly add OSPF extensions to the dense flooding or dynamic flooding and dense graphs. I mean, I think
No. You understand
No?
me wrong. No.
Okay.
He did the ISI, he did the review on the ISIS SRV6 draft, and he said, where's OSPF?
The second bullet.
The second bullet, yeah. So this has nothing to do with dense flooding other than it precedes it in the slide, or follows it in the slide.
Got it.
Yeah.
Okay. Okay. Thank you.
Welcome. Where were we a second ago? Okay. Yeah. So we've been asked by Bruno a while ago to maybe do an adoption on the flooding speed, but there's a lot of testing and stuff going on, and there's still sort of two drafts out there that are talking about the problem is trying to be solved here, which is really kind of a flow control problem, and so. So we feel it makes sense to just, the work's progressing, right? And there are different drafts. So I don't know that we need to rush to adopt one of them or even both of them until we get more experience, which is valuable and happening. So that's our thinking on that one right now. As a working group member, I also think that it would be very cool, since we are talking about flow control, both of these solutions are trying to work within the mechanisms, the existing mechanisms in ISIS, and so there's been objections about tweaking values on the neighbor, and I'm just curious also, if we're looking at this, if anybody's going to think outside the box, and what about just something totally new? I mean, yes, somebody did suggest TCP earlier, I think, but you know, flow control is a well-studied problem. So that's just my 2 cents there, as a working group member.
Yeah, that sounds reasonable, I think, as well. I see we have one more in the queue here. We have Shusong.
One more question here. I noticed that I have seen the young data model for EASE and OSPF SRv6 several times in the working group adoption call queue. I'm just wondering when this will happen as the co-author of these 2 documents. Thanks.
AC,
Yeah. What was that draft that, was it Caridi that had the draft on it will happen next, next IETF or next, I can't remember. It's on the priority list of the adoption. So it's nearing the top of the list, and it's not a controversial draft. I think we should adopt these as for protocol maintenance. Okay. And this is just pointers to these documents that are IGP documents, LSR documents that are on their working groups. I pointed out the second one, the Yang model for MPLS MSD, because we moved that out of the SR Yang and into a separate MPLS document because MSD is independent of SR. And that's it. Let's go to the first, I guess, Yingzhen. I'll get it right.
Alvaro, do you want to, Alvaro?
Yeah, hey, Alvaro Rotano, Routing AD. Just a quick thing before you go into the actual work. I want to welcome John Scudder as the new AD for LSR. I think all of you should probably know that he was just selected AD recently. He's taken over this week. In fact, I think we made it official that he's starting today as AD. Usually the transition happens on Wednesday, but you know, we put all the ADs with AD powers this week. So John is starting today. He's taking over for me as we reshuffled the working groups a little bit. I also want to say thank you to the working group, because when I took over LSR was when we first merged ISIS and OSPF, and I think it has been working very well. AC had sent me a list the other day of that I don't have with me. I thought you guys might project it here, of all the things that have been done in the last I think about 3 or 4 years since LSR has existed, and it is a lot of work. It is really good work for the chairs for shepherding all this work. It is great that to see the working group engaged, and I think even better that we have been able to pull out the 2 protocols working as not as one, but you know, close to each other, and that we see things progressing in both of them. So thank you for that, and welcome to John. He's already doing a lot more than I did. He's already the Jabber scribe. This is great. Thank you so much.
Yeah, Alvaro, and thank you very much for all hard work over the years. Very in-depth reviews. I don't know how any AD does it, to be honest.
Thanks, Chris.
And thanks for the welcome. And I don't know how any AD does it either, but I guess I'm about to find out. Sucker.
Okay.
Okay.
All right, I'm sharing next.
This is one thing that's confusing, that it shows up as you're muted, but you can talk, right, Yingzhen?
Yes, I can talk. Can you hear me, right?
Yep.
Okay, so this is Yingzhen. I'm going to present an update of OSPF transport instance. Next slide, please. So what's OSPF transport instance? It's a separate OSPF instance for non-routing information dissemination. Typical implementation may use lower priority IP packets. So normal OSPF routing instance gets better priority during packet transmission and reception. OSPF transport instance supports sparse topology with remote neighbor. That's just a memory refresh for what's OSPF transport instance. Yeah. So in this new version of the draft, we added detailed encoding. For OSPF v2, we propose a new transport instance information opaque LSA. This slide shows the packet format of this TII LSA. Depends on the application. This new TII LSA can be flooded at any scope levels, link, area, or on AS. Next slide, please. Okay, so for OSPF v3, transport instance information LSA is defined and shown in this slide. Same as OSPF v2, the flooding scope is decided by applications. It can be at link, area, or AS level. So the detailed packet format, you can look at the draft. It's basically just a new type of LSA. So next slide, please. Okay, for both OSPF v2 and v3, we define a top-level TII application TLV. So the application ID used here is to uniquely identify an application. It's the same as defined in RFC 6823, the ISS JINFO RFC. So we already received comments from Les about this application ID registry, and we will working with him on updating the registry, make it ICP instead of ISS specific. So we think this TLV with a defined IANA application ID will make OSPF router application pub/sub implementations simpler. Then there are additional application-specific sub-TLVs that can be used for additional information. That the detail how those things are defined is beyond the scope of this document. Next slide, please. So this slide is a IANA registry summary. So for both OSPF v2, v3, transport instance information LSA, and the TLV definitions. So right now we only have this top level application TLV defined. All others are to be defined in the future. Next slide, please. Next steps, we'd like to collect and address comments, and we'd like to request working group adoption. That's all. Any questions?
Yeah, we got Linda. Yeah, Linda.
Hello, can you hear me? I have a question on your previous slide, I think 6 or 5. You talk about the application ID. This one. Yeah, this one. So this application ID, is it end application or is it network application?
What do you mean end application or network
This
application?
application ID, right? What is that representing?
It's an application that want to use OSPF transport instance to disseminate the application information. We don't really care about exactly what the application is.
So does that mean if I have a specific application, I'm attached to a router, I want to add something into it, I can create my own sub-TLV to be attached?
Yes.
How do I tell my attached router I need this information? Like I'm just attached to, is a prefix attached to a router?
Out of the scope.
Yeah.
Right. Yeah.
Yeah.
Okay.
Just to comment on this, it's really meant for non-routing information to the transport instance. So
Okay.
I guess you could have I guess you could have you don't mean a prefix, you mean an endpoint for an application, I guess.
Right.
Yeah,
Endpoint. Yeah. Yes.
Yeah,
Yeah,
you could do that. Okay, Uma.
Hi, thanks. Can you hear me okay?
Yes.
yes.
Yeah. So I was looking at the draft and possible use cases section. MEC use case is listed, but I really couldn't understand how network resources can be given to 5G UE. So it's very unclear. I don't see this a possibility at all. That need to be corrected, frankly. And the second thing is there are situations where the 5G core nodes and and the PE can be together, like in 4G cases, SE gateway. In that case, the resources you give, network resource information you give, will be useful to the rest of the network, but not even the 5G RAN side, actually, frankly. So it's far off to give to UE. So please comment on this and, if possible, correct it.
Are you addressing this to the 5G presentation that comes later?
No, for this draft,
No.
it's one of the possible use cases it listed.
Oh, I see. I see.
So
Yeah.
this one, OSPF is going to disseminate the net routing information inside OSPF network for sure, right? So for the 5G case, how your UPF interact with an OPF, with an OSPF router. You can run a virtual virtual machine on your, like a Docker process, OSPF process, or something like that, or use some other interface to interact with OSPF. That's out of scope of this document.
Yeah,
we provide
the
a
use case is
means
invalid.
to.
What is described is not
Let's
invalid.
take this to the list, Uma. We'll
Okay.
get the rest.
Yeah, I'll put a message to the list. Thanks.
Okay.
And worst case, you just pull the use cases.
Ajin, did you want to say something before that? Okay.
Tony?
Hello?
Yes.
Okay.
You're up.
Hello. So I'd like to register Tony's standard objection number 1. Routing protocols are not dump trucks. We should not be putting other stuff into our link state databases if they don't need to be there. And this mechanism is not necessary and is going to actually impede the stability and performance of the protocol.
That's why we are using a transport instance. This one is designed for non-routing information dissemination. It doesn't do any route calculation. The basic routing protocol is still run in the base OSPF instance.
You should simply design a separate protocol for dealing with this.
So Tony, did you not like the Gen app with the ISIS either?
Yes, this is not specific to OSPF.
Yeah, right.
As a compromise, that's why we choose to use a separate instance.
Right.
Yeah, I think this owes more time on the list, but thanks.
Ajin.
Hello?
Yes.
Yes, I can hear you.
Yeah, would you like to switch back to the slide, the second slide?
Second slide?
Yeah, here you mentioned that you in the OSPF transport instance, you can transfer information by the non-routing sparse topology. So So what is specifiable? It is need also build different neighbor OSPF neighbor different OSPF neighbor from the normal OSPF instance. And what is the meaning of the remote OSPF neighbor here?
I'm so sorry, but we have to cut this. We're out of time.
Yeah, I think
so can you bring this up on list and everyone else in the queue on this as well?
So I will just answer it quick. So basically it means the transport instance can use a different topology from the base, the routing process, the routing instance. That's it.
Yeah.
And we will answer more in the list.
Okay. Managing windows here. I think Peter, you're up with FlexAlgo.
Yeah, can you guys hear me?
Yes.
All right, so it's Peter Pshenag here. I'm going to give you a quick update on the FlexAlgo draft on behalf of all the co-authors. Next slide, please. All right, so a bit of a context. The working group last call for this draft was done. The publication was requested October last year. We even have the routing directorate review, which is marked as a complete at the moment. While the problem was that the original implementations were mostly ISIS. Now a couple of vendors started to work on the OSPF part, and interestingly enough, in about the same time, both discovered that there's a missing piece in the on the OSPF side. So what we would like to do here is we added the missing pieces on the OSPF side, because otherwise the basic spec would basically not be complete. We were thinking about adding this maybe potentially to a different document, but then we said, well, this is a basic stuff, it belongs here, so let's go back to the working group. So we added these missing parts. We would like to ask the working group to review, and we can do another working group last call. There is nothing changed from the perspective of the FlexAlgo operation or anything. This is just adding some OSPF specific metric information which we have missed in the original text. So next slide, please. So a couple of things which has been added. So first one, in OSPF we have a bunch of metric types in terms of the external information. So the external prefixes can have type 1 or type 2 metrics, something which is specific to OSPF. And when we define the Flex algorithm prefix metric Sub-TLV, the Sub-TLV which is achieved the end-to-end inter-area or inter-domain optimality on the FlexAlgo metric. We added it, but we didn't really think about the type of a metric which is being supported in OSPF. So what we did is we added another field, 1 byte field, which a flag field basically. We carved it from the reserved field, so there's no backward compatibility issue in terms of the TLV layout. And when the bit is set, that the metric type is 2. So this is basically the same functionality that the basic RFC specification mentions in the section that is mentioned here in the RFC 2C28. So this applies strictly to OSPF external and MSSA external prefixes. So that's one thing. Next slide, please. So I don't see any slides at the moment. Okay, it's probably take a while. All right. And the second, a bit bigger piece is that, again, related to the prefix, FlexAlgo specific prefix metric. When we define this, again, we define everything properly for the prefixes, but what we forgot is that in OSPF, inter-area between the areas, we also advertise the reachability of the ASBRs. And it's a type for summary LSA, as we call it in the OSPF specification in OSPF v2. And we completely, missed this part. So now if you want to calculate the path to the external destination, we need to first find out the best path to the originating ASBRs. And in OSPF, this information is being, sent between the areas. So what we define is we needed to have a way for these summary advertisements to provide a FlexAlgo specific metric. So what we define for OSPF v2, we define the extended inter-area ASBR LSA, which is very similar to what we defined for the prefixes, years back, and has the same semantics as a type 4 summary LSA in the base OSPF v2. Then we define the TLV in this LSA, which is being used to advertise the FlexAlgo specific extended information about the ASBR. And then we define the Sub-TLV, which advertises the FlexAlgo specific metric. It can advertise the FlexAlgo specific metric for the single ASBR in multiple FlexAlgos, and this is being sent in two parent TLVs. One is the one which is defined here, the second one, the extended inter-area ASBR TLV, or for OSPF v3, this TLV is also available in the OSPF v3 inter-area route TLV, which is defined in RFC 8362. Next slide, please. And then basically there has been some text added about processing and advertisements of this inter-area ASBR LSA, and also the section 13.1, which is the inter-area or multi-domain section, has been extended with some text that talks about when to advertise this and how to process this. Okay, next slide, please. And the last part, obviously, there are some allocations which are needed. So we updated the IANA section, and once the working group kind of agree on this edit text, we will ask the IANA for the allocation for this new LSA TLV, sub-TLV. All right, next slide, please. So again, this was a mistake from our side. We somehow forgot the specific OSPF piece here. So what I would like to do, and we would like to do as a set of authors, would like the working group to have a review of the edit text, and then we would go over the second last call.
Okay, Gian has a question or comment.
Mm-hmm.
Go ahead, Gian. Gian, you can send audio.
Yeah, can you hear me? Sorry about that. I think I was in the queue for a previous slide, so no comment. Thanks.
Okay.
So did I hear correctly? Basically, we had ISIS implementations that preceded OSPF, and when we got into the OSPF afterwards, it basically showed this missing stuff.
Yes, that's what happened. Yeah.
Okay. Alvaro?
Alvaro routing AD. Yeah, so I just wanted to say that I'm really glad that you guys caught that, and not me, because this was next in my queue. So what I'm going to do is, since we're going to go for another last call, and this seems to be a significant change, is I'm going to bump the document back to the working group, and then you can put it in John's queue whenever this is done. Thanks.
Sure.
Okay, thanks.
Thanks.
Okay, great. Speaking of time. Thanks, Peter.
Okay, we got William or Bill.
Hi everyone, this is William Preto. So today we'll talk about the new draft for FlexAlgo bandwidth constraints. Next slide, please. Yeah, so first we'll talk about why a bandwidth-based FlexAlgo is useful. And then we'll look at the additional FAD constraints that will be needed to define this FlexAlgo. And then we look at some generic FAD constraints which can be applied on any FlexAlgo. And lastly, we will look at an automatic bandwidth metric derivation scheme where if a FlexAlgo can define the parameters and each participating node can compute or derive the bandwidth-based metric automatically. Next slide, please. Yeah, so FlexAlgo provides mechanisms to compute path based on various constraints. So it is a very easy and efficient way where a single definition can dictate how the topology looks like, and each node which agrees to that can participate, and a participating node can look at the topology in the same manner. And this draft introduces a few additional constraints and a new metric type to define a bandwidth-based FlexAlgo. Next slide, please. Okay, so for this FlexAlgo, we define a new metric type. This draft defines a new metric type called bandwidth metric. And so the first addition would be each link can advertise a bandwidth metric, so which would be a Sub-TLV or the application specific link attributes. This can typically be configured per link by the network operator, and it is most likely to remain static unless the network operator wants to change it. So when we floated this draft for review, we received some feedback asking whether can we make this a generic metric so that in future, if you want a FlexAlgo specific metric, or if you have a new metric type coming up and if you want to reuse the same TLV for that. So we are open to that idea. We would like to listen to the feedback from the working group for that. Now, for the bandwidth-based FlexAlgo, we define a few additional constraints, which defines the parameters to compute the automatic metric. And this draft also introduces a couple of additional constraints which can be used by any FlexAlgo. Next slide, please. Yeah, so we look at the additional FAD constraints which are applicable for any FlexAlgo. The first one is an exclude constraint called exclude minimum bandwidth constraint. The name might be a bit confusing, but the aim is that any link whose advertised maximum link bandwidth, if it is lesser than this limit that is defined by this constraint, those should be or must be excluded from the FlexAlgo. So this is useful in any FlexAlgo where you want to say that this is typically useful in a bandwidth-based FlexAlgo where you want to exclude certain links which don't have the enough capacity that you want. And the next constraint is an exclude maximum link delay constraint. So in RFC 8570 dictates or defines the unidirectional or min unidirectional link delay. So this is based on that if any link whose advertised minimum unidirectional link delay is greater than the delay specified by this constraint, those links should be excluded from the FlexAlgo. So this is mostly should be useful in FlexAlgos which do not use link delay as the metric type. So in any other FlexAlgo, if you want to use this as a constraint to remove some things which are very bad, so which has a very large delay, this might be useful. Next slide, please.
So Bill, speaking of minimum bandwidth, you're clipping, your audio's clipping in and out. Could you turn off your video? There's a way to turn your video off. Maybe that'll help.
I think it's already off.
Okay. No, yeah, you're not displaying video, but there's a way to turn it off on the receive side. But anyway, we can keep trying to go, but just letting you know your audio's clipping.
Okay. Okay. Yeah. Can we go to the next slide? Yeah. All right. So now we go to the automatic bandwidth metric calculations. So here, the flex algo can define or advertise certain parameters which each participating node can look at and use them to derive the bandwidth metric. So this is applicable only for the flex algos whose metric type is bandwidth metric, and this automatic metric calculation will be done or should be done only on the links which do not advertise the bandwidth metric Sub-TLV. So the entire automatic bandwidth metric calculations are based on the maximum link bandwidth already advertised per link. So we define two modes of automatic bandwidth metric calculations. One is called simple mode, and the next one is called interface group mode. We'll look that in detail in the next slides. Next slide, please. Right. So in the simple mode, it's probably useful for or suitable for deployments using layer 2 bundles for all the parallel links between two nodes. The maximum link bandwidth advertised per link is used to derive the bandwidth metric. Next slide, please. Right. So in automatic bandwidth metric, flex algo has additional work. Basically, flex algo will have to identify and group the parallel links participating in that flex algo. So you look at the IS neighbor, the link advertisements, and look at the neighbors and group all the link attributes which are pointing to the same neighbor. And then the sum of the maximum link bandwidth advertised by each of those parallel links is used to derive the bandwidth metric applicable for all those links. So the derived metric is then assigned to each parallel link. So this is suitable for deployments having parallel links advertised in IGP where you don't necessarily have a layer bundle. Next slide, please. Right. So so we have two methods, as we said, the simple mode and interface group mode. And now we look at how two different types of methods to derive the automatic bandwidth metric. So these are again additional parameters which dictates or defines which a flex algo defines to compute the bandwidth metric. So you have two methods, a reference bandwidth based method and a bandwidth threshold based method. Next slide, please. Okay, so in the reference bandwidth method, basically the flex algo defines a reference bandwidth which can be used by each participating node to derive the bandwidth metric. So this is done by advertising a FAD Sub-TLV called reference bandwidth Sub-TLV. It has a flag to indicate whether to use the symbol or interface group mode. And it has the reference bandwidth, which is used to derive the metric, and it also has a round-off bandwidth. So the round-off bandwidth, basically, it helps to round off the link bandwidths by each link into a multiple of that value, so that you have more uniform kind of metric or stepwise metrics across the topology. And the algorithm or the formula to derive the metric is shown here. So you define the reference bandwidth by the link bandwidth, which is a multiple of round-off bandwidth. So as you can see, as the bandwidth increases, the metric decreases. Next slide, please. Yeah, so this is one of the examples where the reference bandwidth is defined as 1 Tbps, and you have a round-off bandwidth of 20 Gbps. So the benefit is that if the link bandwidth is somewhere in the range of 100 to 120, for example, the metric would be 10. So if the link is an aggregate internet link or a layer 2 bundle, if there are member links going down, so even if the bandwidth doesn't change by much, the metric wouldn't change as well. Next slide, please. So this is the last method called the bandwidth thresholds method. This is basically when the reference bandwidth method basically has a proportional or a inversely proportional metric where the metric is almost directly inversely proportional to the reference bandwidth that is defined. If the operator wants to have a different set of metrics for a different set of range of bandwidths, you can use this method. So the bandwidth threshold sub-TLV will have a staircase model where certain thresholds are defined and the corresponding metric is defined. We can look at the example in the next slide. Can I go? Please go to the next slide. Right. So here we have an example where you defined thresholds, like you have the bandwidth threshold 1 min as 5 gigabits, which basically says that anything less than 5 G bandwidth should be given the maximum metric, and any bandwidths, which is any of the link bandwidths which is between 5 to 50 Gbps gets a metric of 5,000, and anything between 50 and 100 gets a metric of 50, and anything similarly anything above 100 Gbps gets a metric of 25. Next slide, please. Right. So based on the review comments, we'd like to call for working group adoption. Questions?
Hey, this is AC, more or less speaking as a working group member. I think this is a good example of how flex algorithm can be used. That, you know, a new algorithm defined, which is, you know, with different metrics and constraints. I think this is really, really good. I had one more comment. I noticed there's a lot of, you know, whenever we talk about delays and things, there's discussion on the measurement of these things, which is kind of out of scope. I mean, you should precisely define it, but how to measure it, I don't know that you need to. But it would be good to provide guidance on how often it is and how frequently it's updated. Thanks.
Sure. Thanks.
Okay.
Yeah, so I had a question about, so, you know, from the list, I guess the discussion about the metric, so, and the use of, I guess, real-time bandwidths to update, I guess, the metric that's used in the FAD calculation, and static, I guess, versus dynamic values. And I guess also the discussion related to possibly like instability with the metric changing. I guess that was one of the concerns. So just wondering, I guess, let's say you have thresholds that are set, and based on that, you can include or you can exclude different links, similar to like an RSVPT exclude type function, which makes sense. But I think the bigger question, I guess, related to instability, and maybe you can talk about that, just how using these dynamic measurements, I guess, to update the metric, and how that will not prevent, you know, cause any type of instability with the IGP. Thank you.
Right. Thanks. Yeah, so the exclude constraints which have been introduced by this draft, we expect that the operators use them with caution. So in most deployments, when you want to bring down a link, if the constraints are not met, it is very likely that you have alternate paths available. So yeah, so when you use that constraints, you have to define the thresholds as well, and make sure that the topology is safe for that. One more thing regarding bandwidth is that the bandwidth, when you said dynamic bandwidth, it's again the link bandwidth, which changes only when a member link can go down.
So we are, unfortunately, with 1 minute left in this presentation. Uma's next in the queue. I don't think we're going to get through everybody else. I don't know have any way to cut, to end the queue in the interface. So, and I didn't want to interrupt. So go ahead, Uma.
Okay, so thanks, Chris. Actually, it's very useful draft, and in some cases, very useful. But one thing I would like to see in this draft is discussion about the changing metrics. What is the impact of the packet reordering, right? So if it actually changing, right? So if that is discussed, that'll be good.
Okay.
Go ahead, G.
It's an interesting topic, and I've seen a lot of discussion on the mail list. I have maybe two comments. The first one is the bandwidth metric, new metric on the bandwidth. Is it tightly coupled with flash algo, or it's just a generic new metric TLV?
Right. So the bandwidth metric Sub-TLV, which we have introduced in the draft right now, it's generic. It's applicable. It can be used by any application as well.
Yeah, if that's the case, maybe it's better to clarify that it can be used in more general cases. And the second one is the latency and bandwidth constraints. I'm not sure whether they can be treated in the similar way, because latency, you need to count the accumulated latency for end-to-end pass. If you just use a constraint as a maximum latency on a particular link, is that really, what would be the use case for that kind of constraint?
Right.
If you don't count the hops.
Right. So as I said, if you want link delay based traffic, you are most likely to use link delay as the metric type. But in any other flex algos, if you want to define very high link delay value, where you want to say that if a single link is performing very badly, you want to exclude that link from flex algo. So this constraint can be used in such cases. So it's definitely not it's not interfering or doesn't have a say in the metric value. It just is used to exclude certain links. So you don't just by excluding, you don't get a very good link delay or the shortest path based on link delay. You just can modify your topology or prune certain links from the topology. I hope I answered your question.
Shraddha, you go ahead, and then I don't know if we can't do whoever's last.
Yeah, so I just wanted to provide clarification regarding the bandwidth, exclude bandwidth and exclude delay constraints. So it's basically a way of excluding certain links based on dynamic measurements. So if the measurement is static, then we really don't need to come up with new constraints, because link colors can already do what is required. So this is specifically to improve operations when these link bandwidths are changing dynamically, especially when in case of L2 bundles, the bandwidth changes dynamically. And similarly, when dynamic delay measurement is used, the latency of the link changes dynamically. So with respect to actual measurements and how often that is flooded, the delays get flooded, that is kind of out of scope for this document. So it's mainly saying providing an ability to advertise a constraint that says exclude a certain link which is having certain threshold delay value. So that's pretty much it is doing. So I just wanted to clarify that. And yeah, we will add text about the clarifications that William provided on with respect to, like, if the area partitions because of this dynamically changing values, either bandwidth or delay, and how operators need to care for that. Thank you.
Thanks. Okay, up next, I don't remember who's presenting. Zhongjing? Or yeah.
Yeah, Young Gene's, his audio's on, so he must be presenting.
Thank you. I'm Zhu Yunqing from China Telecom. My presentation is using flex algo for segment-routing-based VTN. The last meeting we did the presentation about the first draft to RSI as it is SRVT Flex Argo version 1. This time we revised the draft and did this presentation. Next slide, please. Let's look at the background. A VTN is a virtual underlay network with a customized topology and a set of network resources, which introduced in draft IETF's enhanced VPN as the underlay of VPN plus services. And SR-based VPN is described in draft IETF Spring SR for enhanced VPN. It provides the mechanism and procedures to build SR-based VPN using resources and resource-aware feeds. And in some scenarios, each SR VPN can be associated with a unique Flex Argo. This document describes the Flex Argo-based control plane mechanism for distributing the topology and the resource information of SR VTNs. Next slide, please. Next slide, please. Let's look at the mechanism. Flex Argo ID is used as the control plane identifiers of a VTN. In this part, we use Flex Argo to describe the topology constraints for a VTN and use as SR to advise algorithm-specific prefix seeds or SRv6 locators. We extended as R2 bundle to advise the TE attributes associated with VTN. That is, we use as R2 bundle to extend it for both virtual and physical member links. In this slide, you can see that the V flag indicates the member links are virtual links that share fit with the parent L3 interface. Each VPN is associated with one virtual or physical member link in the bundle. We use the main group, that is the color, or to correlate the Flex Argo and the member link. The T attributes and the SR seeds of the member links belong to the VPN. Next slide, please. At the last meeting, we present the version 1. This time we update in we do some modification in this version. That is, we clarify the limitations in the usage of admin group constraints in Flex Argo definition when Flex Argo ID is used to identify a VTN. Which only include any admin group rule can be used. And add descriptions about the usage of the V flag. We update the reference to draft IETF Spring SR for enhanced VPN. And there are some editorial changes. Next slide, please. Next step, we would like to ask for work group adoption for this document. Thanks.
Tarek.
Hi, this is Tarek from Juniper. My question is related to the use of Flex Algo to achieve what you're trying to do. As we know, Flex Algo comes with overhead of advertising the definition and then nodes consuming the definition and doing SPF with the respective algorithm. You will soon realize that you cannot do as many Flex algorithms as you would want. Is there any consideration about the ceiling that you will be hitting soon with this approach? Yeah, that's my question. I'm not sure if you heard my question. It went silent.
Well, yeah, he's muted right now. Also, Ji, you're in the queue, but you're as a co-author, I believe, right? So you can just unmute and answer questions.
To answer that, I think regarding the scalability in this draft, there's a section about the scalability considerations, which talks about the possible limitations using the Flexible ID as the identifier of VTA in the control plane. And for better scalability, we also have other drafts which can support multiple VTNs, share the same topology, and that one requires some more extensions to the control plane. And maybe we can have some further discussion about that topic later. Yeah.
Thanks, G. Just why do we care to standardize something that we know it's not scalable?
Yeah, we have another draft about the scalability considerations in TEAS. And because we can see different scenarios can have different requirements on the scalability, and and each mechanism has its pros and cons in terms of the complexity, the changes to the protocol, and the scalability is just one aspect of that.
This seems like something that would be good to discuss in the list. I think it goes to the heart, of the draft before we start talking about adoption. Yeah, so let's move to Peter because we get 2 minutes left.
Okay, so so what you seems to be trying to achieve here is to advertise the VTN specific information about the link. I don't question the approach. That's probably a different discussion. But the way you're trying to do this is that you hijack the L2 bundle advertisement, and you are trying to pretend that this is some kind of a virtual connection which is specific to the VTN. I'm not sure that's the right approach, and even the worst thing I see is that there's no direct information about the VTN for which you advertise this information. You have to specify some specific admin groups that are matching the FlexAlgo definition to pair this type of information. I don't think that's the right way of encoding the things. This is very error prone, and I would not prefer people doing that. I mean, if you want to advertise a VTN specific stuff, define a VTN specific information and put it there, and don't hijack the existing ones and then map it via some third party value. So that is my comment here.
So as a working group member, when I read this draft, when I saw the admin color used, I was hoping to see that this was just going to be able to be informational, right? So when I see admin color being used, a lot of times it's because we're going to reuse mechanisms without having to do any normative changes. Anyway, I can't read the name, unfortunately. It's Z, but it's too cut off in my display. You go ahead from the queue.
You mean Robin?
Yeah, I think so. I literally only have 2 pixels of the names displaying on my screen, so it's hard.
Go ahead, Robin. Okay, maybe it wasn't.
Okay, before Robin can talk, can I briefly answer Peter's comments? The way we choose to reuse the admin group to map correlate with Flux Algo ID is based on the existing Flux Algo mechanism to correlate a link with the Flux Algo definition. This is to minimize the changes to the protocol. If we introduce a dedicated identifier for ATN, that is another approach that will require more protocol extensions, and we can also consider about that if people think the Flux Algo based correlation is error prone. And that is what Flux Algo is defined.
I definitely think this is good for the list, by the way. It's
Sure, we
because,
can move
you know,
into the list.
I think people might have opinions on both sides.
Yeah, maybe we can have more discussion on the list.
Yes, thank you. Next up is the L2 bundles. Also with a normative bit. Ron?
Hi, can you hear me?
Yes.
Yes.
Yes. Hello, everyone. I'm Zan from ZTE. Today, I will talk about IGP flexible algorithm with L2 bundles. Next, please. Yes, this is the motivations. This draft describes how to create flex algo with L2 bundles scenario. Next, please. This is for IGP L2 bundle member extensions. RFC 668 defined TLV25 for ACS to advertise the link attribute of L2 bundle members and mentioned that the traditional administrative group sub-TLV and extended administrative group sub-TLV may appear in TLV25 and may be shared by multiple L2 bundle members. If we want to advertise unique extended administrative group values for each bundle member, we can use multiple L2 bundle attribute descriptors with each specify a single bundle members. No extensions is needed. And LSR OSPF bundles draft also defined L2 bundle members attribute sub-TLV for OSPF version 3 to advertise the link attribute of L2 bundle members, and mentioned that the traditional administrative group sub-TLV and extended administrative group sub-TLV may be contained in L2 bundle members attribute sub-TLV. Because there is L2 bundle member attribute sub-TLV for L2 bundle member, it is also sufficient to construct flex algo plan to select L2 link results. But in this draft, we only extend flex algo definition flags. We extend a new flag of this flex algo definition flags sub-TLV and OSPF FAD flags sub-TLV to let each node to check L2 members link resources of interface bundle during flex algorithm path calculation. Next, please. History. We submit the version 00 in December 2019, and the following updates were made in version 01. The first is we remove L2 bundle members, extended administrative group extensions. The second is we reuse L2 bundle members attribute TLV sub-TLV with traditional administrative group sub-TLV and extended administrative group sub-TLV based on discuss on LSR minute. And the version 03 and 04, we add the flex algo L2 bundles use cases and add the FAD flex extensions. In version 05, we add co-author Yongqing from China Telecom, and some editorial changes. Next, please. Comments welcome, and this draft is in stable state in version 04, and all the authors would like to ask for working group adoptions. That's all. Thank you.
Go ahead,
Peter.
Okay, so my very basic comment here is, I mean, as one of the co-authors of the FlexAlgo specification, we never attempt to use L2 links in the FlexAlgo calculations. I'm basically asking whether is this something we want to do. I guess the right solution for this is an SRTE, where the SRTE can use all sorts of information to do the constraint-based SPF. It is possible to do it inside the FlexAlgo. I'm not saying it's impossible. I would try to keep the FlexAlgo calculation being L3 specific and not being used the L2 information. So I guess the right solution for this is the SRTE, not the FlexAlgo.
Thank you, Peter. Thank you very much. Thanks for your comments. Yes, you have seen some mails, and we have discussed it. But I still think the problem that the FlexAlgo uses for out bundles needs to be solved. In section 5, we describes the FlexAlgo bundle use case and examples. Yes, I think we can discuss it. We hope to get more comments to solve this problem together. Thank you.
Yeah, it might be good if people, there's already been some discussion on the list, but if you have strong opinions about this, please post them on the list. All right, good. Let's make up some time here. Thank you.
Thank you.
IGP adjacency SID advertisement.
Right.
Yeah.
Yep.
All right.
Yeah. This is talk about algorithm-related IGP adjacency SID advertisement. Next, please. Motivations. Algorithm identifier is often included as part of a prefix SID advertisement that may be not satisfy some scenarios where multiple algorithms share the same link results. This document complement that the algorithm identifier can be also included as part of adjacency SID advertisement. The method introduced in this draft enables the traffic of different FlexAlgo plane to be distinguished on the same link, so that this traffic can be applied with different queues policy per algorithm. Next, please. FCC 8667 describes the extensions that need to be introduced for segment routing operating on a MPI state plane. It defined adjacency SID sub-TLV and line adjacency sub-TLV. According, this draft defines two new optional sub-TLVs. Is this adjacency SID per algorithm sub-TLV, and is this line adjacency SID per algorithm sub-TLV. This is the adjacency SID per algorithm sub-TLV has the following format. The algorithm field contains the identifier of the algorithm the router uses to apply algorithm-specific queues policy configured on the adjacency. and the SID, label, index, and the weight fields refer to the agency SID sub-TLV. And the below is the format of the line agency SID. It also extends algorithm field. Next, please.
So can we, if these are just replications for the 3 protocols, can we go past them? Or they're the same TLV,
yeah.
right?
Yes, that's the same. Yeah. Next, please. We request review and feedback from a working group. That's all. Thank you.
Tony, you're in the queue.
Thank you. So, we already have ample mechanisms within FlexAlgo for doing link assignment to an algorithm, such as administrative coloring. Why do we need this? Crickets.
Ron, you're muted.
Yeah. Yeah. Yes. In the motivation, I have reduced that algorithm identifier is often included as part of prefix SID advantage, but not satisfied some scenarios where multiple algorithms share the same link resources. So we extend this draft.
I'm not following you, but okay.
Okay, thank you.
Well, why don't you post that? I mean, if you don't mind, why don't you raise that a question again so it can have more discussion, Tony? On the list, I meant.
Okay.
Yang
Chris?
Mao. Yeah, just getting better.
Yeah. I'm sorry, I might have cut people off too in an effort to move it along.
No, it's okay. We need to make up some time.
Yeah. Tariq?
Tariq. Everybody, my name is Tariq Saad, and I'm going to talk to you about some extensions for segment routing SIDs that are advertised in IGP to associate them with slice aggregates. Hopefully this is going to be very quick presentation. So please move to the next slide. So I'll talk a little bit, I'll give pointers, in fact, about the overview, and then the encodings very quickly, and then I'll mention the next steps. Next slide, please. So in the first draft NS packet, we are introducing 2 new concepts, a slice policy, which is used to instantiate resources for a slice aggregate, and a slice aggregate is a collection of packets that get the same forwarding treatment on a shared resource. This draft will be presented on Tuesday in the TEAS working group, in case you want to follow that. The second draft is the scalable NS. It's a spring working group. It's a spring draft. It will hopefully become a working group draft. But it's proposing how do we create or instantiate these slice aggregates in an SR network. And one of the options proposed is to allocate different SIDs for the same topological element and associate it with a slice aggregate. Again, packets forwarded with that specific SID associated with the slice aggregate it gets the forwarding treatment that was allocated allocated for that slice aggregate on the path. Next slide, please. So for this, we need to in RFC 8667, the encodings for the SIDs, prefix SID and adjacency SIDs are defined. We need to carry a new identifier and those TLVs for the prefix SID and adjacency SID. It's a 32-bit identifier that we are proposing to carry in the advertisement. And using this, we can advertise different indices for the same prefix. And then that will result in SRMPLS to different labels resolved in the sRGB. Again, the forwarding treatment is defined in the slice policy, which is outside the IGP extensions here. Those are defined in the other draft. Next slide, please. So this is similarly for a adjacency SID TLV. We are proposing to add this 32-bit identifier. And this way we can associate multiple SIDs to the same adjacency for different slice aggregates. Next slide, please. Thank you. And next year, we are talking about the SRv6 instantiations of SIDs. And we specifically for the end SID, the base draft for SRv6 IGP, SRv6 extensions talks about a optional Sub-TLV. And using the same, we are proposing an optional Sub-TLV that carries this slice aggregate ID. Again, it's a 32-bit identifier. So the objective, at very high level, is to associate a SID with a slice aggregate using this 32-bit identifier. And the specific treatment is defined using a slice policy, which is outside the scope of this draft. And I think that's about it of what I wanted to technically present. In terms of next steps, this is the initial draft. We welcome review and comments. We did not define the OSPF encodings in this version of the draft, so subsequent versions will include that. And any questions, you're welcome.
Casey, you're first.
Okay. I don't have any questions. Just as a working group chair, I think that the whole slice TE would need to be adopted in T's first, right? You're targeting that and this concept, and whether or not this concept of a slice aggregate is the right one to satisfy the requirements. That's before we just jump to the encodings.
Yep, we definitely, we are going to push for adoption of the draft that we're presenting in T's. And for the slice aggregate definition and the slice policy, those we are going to work with the people driving the framework for slicing and try to include those terms in there as well.
Peter?
So Tarek, how many of these slice aggregates are we talking about? Because you just mentioned that FlexAlgo doesn't scale. It's if we wanted too many of the slices, which I tend to agree, it's not 400 of them. So how many of these slice aggregates are you expecting to have?
So that's a good question, and I don't claim to have the final answer on it, but we've heard from different customers different requirements. We have to be realistic. We're shooting something in the order of, order of hundreds to 1,000 slice aggregates within the transport network. The point that our proposal, we want to decouple the computation, as you saw I did not mention any FlexAlgo. It's in line. Okay. Yeah. It does not impact the computation of the next hop by IGP. But I don't claim to have the final answer on the number of slice aggregates that will be present in the network. But we want to keep it up, keep our options open in terms of scalability.
Well, you're just advertising hundreds or thousands of these.
Yeah,
it could be a scalability issue. Right?
Hundreds of SAIDs. So you'll have that's what prefix SIDs will be bigger than that, right? Depends on the size of the network.
Yeah. Okay. Well, I guess we understand each other and the concerns.
I want to complete it off, but by mentioning that the proposal we have in spring has two options. One does not dictate this IGP extension at all. It's a data plane. We carry the slice aggregate ID in the label stack, for example, or separately in the packet. It's carried in the packet. But
Yes.
people, there are implications, obviously, for hardware to inspect this specific extension for carrying in the packet. For those, we are proposing this type of extension.
Okay, thanks. G, do you have something quick?
Comments. The first is the drafts you mentioned in TIS and Spring. In my opinion, there's maybe some conflict overlaps with other existing work like enhanced VPNs. So perhaps that could need to be resolved, and then we can talk about the IGP extensions.
Yeah, we're presenting in the TIS working group, G, and we definitely want to reach out to the existing, if there's anything there, we're open to discussing it.
Okay. And for the scalability, we also have a draft in TIS talking about the considerations in the control plane, data plane scalability, and optimizations. We can also maybe talk about that one.
Okay, Uma, last comment.
So the question is like, if said hundreds of thousands of slice aggregates, why are we putting 32-bit identifier here?
No, sorry, I didn't mention 100,000. I said 100 to 1,000.
Yeah, 100 to 1,000, but you put 32-bit SAID here.
Yeah, in the 100, yeah, less than 1,000, I mean.
Yes, I got that. But then why do you represent the SAID 32 bits? That's a minor question at this point, but just think about it.
Okay.
It's a good comment. Yeah, we will think about that. In fact, yeah, we're open to crunching that if we need to, Uma.
I'll just say, if that's the only problem with this, I don't think it will be a barrier.
No. I'm just.
All right. We need to go. Linda.
Linda?
Are you here? Are you here, Linda?
Yeah, she's sending audio now.
Can you hear me now?
Yep.
Hello?
Yep.
Oh, good. Okay, so here we want to present the OSPF extension for the 5G edge computing services. Even though this is the first time we present at this LSR group, we have got quite a few comments, and we have changed the draft according to those to address those comments. Next slide, please. Okay, so here's some background of 5G edge computing environment. So there's a 5G core system. From the UE, you come to the UPF or PDU session anchor, and then there's a router, and then there's in 5G term is they call N6 interface. That's basically multiple local data network. Local data network, and for some sensitive services, mission critical services, there will be multiple servers in the close proximity in the mini data center close to the UPF function, like close to the base station. There are many use cases for those mission critical applications. And the basic network assumption is all those servers are attached to those routers directly in the mini data center. The distance from those egress router to the application server are very minimal. They are co-located, so we're not considered in this environment. The distance. Okay, next page, please.
Chris has a comment on this one.
Okay.
On your picture or question.
Okay, no, go back.
No, I'm actually just in the queue for the end.
Oh, okay.
Oh, okay.
Sorry, I took you off. Get back in. Okay.
Okay, so let's continue on this page. More and more often, the Anycast has been used for many applications. There are many advantages of Anycast. First of all is the Anycast basically leverage the network proximity, allow the traffic to be forwarded to the optimal destination with network condition in mind. Second, eliminate the single point of failure. Like you may have an application load balancer. If the network reachability to the load balancer fail or congested, the traffic performance services deteriorate. With Anycast, the network itself be able to leverage the information and be able to forward it to the optimal destinations. It's truly the network help the application to perform better. And also avoid some UE or client using the stale addresses in the cache instead of a query DNS for the refresh addresses. Okay, but they also have problems. The problem with Anycast in the 5G edge computing environment is the routing distance to multiple edge servers are very small, and there could be unbalanced distribution because of UE mobility, moving from one cell station to another. It could be many UEs attached to one cell tower, all try to access the same server. So you could cause the problem of one server being overly utilized and others being underutilized. And there's also problems when new servers being added, removed. All those can cause problem in this for Anycast services in the 5G edge computing environment. Next slide, please. Okay, so for the Anycast in the 5G edge computing environment, to select optimal server, optical Anycast server, we kind of narrow it down to selecting the egress router, because the distance from egress router to the Anycast server is minimal, is negligent. So that from network perspective, the criteria is really to finding the matrix, like for example, round trip time to the egress router. And on top of that, there will be other factors in determining the optimal egress router. One is the capacity. For example, for the server, Anycast server attached to router R1 can be higher capacity than the Anycast server attached to R2, simply because there's could be thousands or hundreds of servers attached behind a load balancer. From network perspective, we only see the load balancer, the front end. And so it is preferred to be able to forward the traffic to a location where the capacity is higher. Second is the site preference. The site preference could be that the network, the bandwidth to R1 or within R1, the mini data center, is much higher than R2 perspective. So all those factors need to be considered in selecting the optimal egress router. Next page, please. So here we want to show that in the LSR, in OSPF, if all the egress routers are from same vendor or from under the same management system, that they can have the consistent algorithm to calculate the aggregated cost, meaning the cost including the round trip delay and the site capacity, the site preference. They can be making together a consistent value. Then there's nothing need to be changed for the OSPF. We can use existing the Sub-TLV existing encoding and be able to for IPv4 and IPv6 data frame, right? The network. So we basically in the IPv4 we just encode encoded in the matrix field of the stub link as LSA. For the IPv6, we can use this this particular matrix field in the intro area prefix LSA to carry the aggregate cost to the application server. Next page, please.
We're running short on time. Are there going to be a lot of TLVs? Can we skip forward?
Oh, okay. So just two more TLVs. So
okay.
Yeah, 2 more. Okay. So but for environment where that not all egress router can have a consistent algorithm to calculate the aggregate cost, or some environment where some router need more detailed information, and then we need a special sub-TLV to carry the information, which include load measurement, capacity index, and site preference. And this is based on the email mailing list discussion that we're using this extended prefix opaque LSA to carry those information, carry those sub-TLVs. That's for IPv4. Next page. For IPv6,
this is the same.
Yeah, this is the same, but just using the same. So we want some feedback from the group on this proposal.
So I put myself in first because I definitely looked through this. There's a lot of this is a working group member, not as chair, but there's a lot of philosophy going on here. I don't have time to go into, but fundamentally, it seems like what you're trying to do is push application load balancing into and have routing do that job, right? You're asking routing to do the application load balancing. That's a pretty big ask and a pretty big change. You're having to add this information because Anycast is there to solve this sort of simple problem, right? I've got a bunch of servers and I need to go there, and Anycast works for that. But it doesn't work for you because you want to do a lot more with it, right? And so you're having to add all this stuff. I think you're going to get some pushback on the whole idea, because I don't think people are going to be happy with trying to use the routing system as an application load balancer. You can do this in other ways, right? That's my general comment.
Okay, actually in the 3GPP, there's a project called Edge Computing. Over there, Anycast is proposed as the way to balance the traffic. This is not try to replace the load balancer. Load balancer still could be there in any of the mini data center when you have multiple servers, or you have a load balancer, application load balancer among multiple locations. You could have a load balancer, application layer load balancer there. This Anycast is really for the environment where you have multiple load balancers in the network, not just one.
No, I understand, but you're basically saying I want to use Anycast, but but I don't want it to just pick Anycast based on routing. So I'm going to add all this extra information, right? Right. So you're not happy with the Anycast. You're expanding the concept, and that's a big thing. Right? That's all I'm saying. I'm not saying good or bad. I'm just saying it's a big ask. I don't want to be the only one that talks. Go ahead, AC.
I'm going to take mine to the list. I'm just going to say I'm happy that I see today you fixed the encodings in the draft, because that was going to be one of my comments, and I looked at the latest version and it matches your slides. But I'll have the rest of the comments to the list. Thanks.
Thank you.
Thank you, Linda. Okay, prefix unreachable. Go ahead and start talking if you want.
Okay. Hi, my name is Guion Mishra with Verizon, and I'd like to go over the draft prefix unreachability announcement. Next slide. There we go. Thank you. So we went over this draft on the last IETF, and from the feedback from the work group as well, mailing list, as well as the last IETF, we've done a revamp on the draft and really honing in on the issue the use case that this solution would solve with this prefix and reachability announcement, and really cleaning up, you know, all the other related items within the draft. So really just a single issue problem, and you know, with this motivation problem statement, and then a solution, kind of marrying the solution to that problem statement. So with that, so the motivation behind this draft is it's based on either a MPLS exact match on a host route effect binding, or an SRv6 BGP service overlay using traditional unicast URIB longest prefix match in a scenario where the IGP domain is carved up into multiple OSPF areas or ISIS levels, and summarization is utilized. So that's really the key use case where we're honing in. So in this use case, summarization of inter-area routes are propagated into the backbone area for flood reduction, and made up of component prefixes. And in this use case, and we'll go over in a further slide, are really the BGP next hops that are being flooded. So with the summarization, what happens is these components of the summary are now masked and just sent as a summary. So what this feature does with this prefix unreachability announcement, it's these prefixes that we're now able to track and prevent an outage, a black hole of routes, the dead end on an ABR when a failure occurs. Next slide. So as I said, we've completely revamped the draft. If you haven't had a chance to look at it, we'll discuss more on the mailing list following this IETF call. But the updates of the draft is really just honing on this one use case that's related to summarization, and it's a BGP next hop tracking of VPN overlay services. Next slide. So the scenario at a high level, I think, of what would happen in this particular use case. So let's say you have a router R2 and R4. They're generating a summary route. So on the right side within the area 0, they're sending a summary over to area 0 and area 1, and then you have a VPN overlay. So you have a VPN routes that are being learned between S2 and T2, S2 on the left and T2 on the right. So when there's a failure that happens, let's say a node failure, so T2 goes down, you still have a summary that's being advertised from R2 and R4 back over to R1 and R3. So when that LSP gets built across the area, it ends up dead ending right on the ABR on R2, and you're basically you're basically black holing traffic going to T2. The convergence doesn't happen, the failover, because the component prefixes that they're represented by that summary address are not there. So this feature related to summarization with MPLS, it's related to RFC 5283 with the inter-area LDP extension. This same concept, and we'll go through it, it actually applies as well to SRv6, where you're doing longest prefix matching as well with it. So with MPLS, with the LDP RFC 5283, you end up doing a longest prefix match because you're creating a summary. But now with the component routes not being present with the summary, you're not able to track it, and thus you're just really black holing right on that ABR. Next slide. So this slide shows a similar, basically a dead end that happens when the LSP gets built. So you have the same similar failover that happens, but it's a link failure versus a node failure. So instead of T2 going down.
Yeah, can we expand this one along? This is pretty much the same use case from that standpoint.
Yeah, it's the same use case. We can go over to the next slide. Thanks. Okay. So upon receiving a link or node failure with the PUA mechanism, it uses a ISIS IPv4v6 source router ID Sub-TLV described in RFC 7794, or with OSPF the prefix originator Sub-TLV described in the LSR OSPF prefix originator. So with that, it actually creates a that it's advertised the source router sub-TLV of where the failure is advertised and flooded through the domain using standard OSPF and ISIS procedures, but now with the originator information set to null, dev/null. Next slide. So with the scenario with the node 1 failure, when the node within the area receives a PUA message, it floods into all the ABRs, I guess, within the area, and so that triggers when the failure happens, the TLV is flooded through the area, and now with the next hop set to null 0 of the failed linker node, and that triggers the control plane to fail over from the active LSP to the backup LSP. And the same situation with the Lincoln node failure. It's the exact same failover. Now the LSP is able to rebuild onto that backup path. Next slide. So, as I had described earlier, so the scenario, so it's related to the crux of it is instead of having to flood all of your loopbacks or your BGP next hop attribute like throughout a domain, especially where you're carved up and you want to save on your control plane, and you want to be able to use summarization using, let's say, the RFC 5283 in the MPLS scenario, inter-area extension, and you want to make that viable. Or if you're in an SRv6 scenario where you want to do that as well, but you're still doing longest prefix match. But you want to be able to track those component prefixes related to that next hop attribute where that linker node failure happened, and now you've got a dead end right on the ABR during the summarization. So with this solution, it basically provides that negative PUA that can get sent out to track that next hop that's down and force the control plane to converge from that longest prefix match that went down now to the backup path. So forcing that immediate control plane convergence. Next slide. So this slide is really describing the scalability. So this is being able to utilize summarization where you have thousands of PEs, and imagine you're flooding your next hop attribute throughout the domain, and so eating up control plane resources. So now with this, you're able to really take advantage of summarization, and you don't have to flood your host routes throughout the network. And now you can converge. When those component routes go away, now you have this negative advertisement that goes out to track the next hop that has gone down from a linker node failure, and now you can converge onto that backup LSP. Next slide. So one of the considerations with the PUA feature is a concept of a maximum.
I'm sorry about this, but we have to cut off very soon because we have one more presentation.
Okay.
7 minutes.
Go ahead. Go to the next slide. Thanks.
Okay.
This is the final slide. So I would like to ask for comments from the work group based on the updates of this draft and ask for a work group adoption. Thank you.
Speaking of working group member, I have 2 comments. I think I made them last time too, but they weren't taken. The first comment is, how do you know what holes you're protecting in the summary? Are you going to configure those on the ABRs?
How do we know which
prefixes? How do you know which holes in the summary that you're protecting? Are you going to configure those on the ABRs?
So it would protect any. So with that the originator sub-TLV, as long as the prefix is within that range.
No, you're not getting my question. How do you know a priori? How do you know whether or not that you're missing? Say the ABR comes up. How does he know what he's missing if it's not configured?
Right. So I don't know if I'm completely understanding your question, but let's say if the prefix is missing within the range, that notification happens from the sub-TLV originator.
So you're assuming that
we got to switch.
Yeah, you only lose. Okay, you're assuming that you know about the prefix and then it goes away. You're not going to protect something that's going away that you want to protect that you don't know about when you come up because it's stateless, right?
That's
Okay.
true. So anything that you know about, I think it's something.
I mean, you have to know about it. Okay,
Within the range.
so it's somewhat timing. It's somewhat timing based. It's kind of broken in that way. The other one I had, the other question is, and I made this before, is the way you're encoding it. If not everybody in the domain supports it, you're going to actually attract traffic towards the black hole, and the prefix originator is just the wrong method for this. That's all.
All right.
Okay, next
Thank
up.
you. Thanks. We'll take it to the mailing list on this comments. Appreciate the comments. Thank you.
Thank you. I don't remember who's presenting.
This is Yali.
Yeah.
Please go.
Hi.
You got 5 minutes. Sorry.
Thank you. And this is Yali. Yeah. And I think the time limited. So do you mind to go to the third page directly? I think it's talk about the motivation and goals.
Sure.
Yeah. Thank you. And first of all, we can find that with the increasing use of the existing mechanism to disseminate types of application information, much more burden are generated in ISIS protocol. So in addition, advertisements of such additional information not directly related to ISIS may potentially impact the routing, coverage, and the stability. So we found that an existing TLV named generation information is defined to disseminate application information. And but we found that the advertisement of generate information must occur in the non-zero instance of the ISIS protocol. Hence, we find there's requirements that in information carried in generic information TLV should be associated with another information carried in other ISIS instance. So in this draft, we try to eliminate the potential impact on the routing, convergence, and the stability, as well as avoid the association issue. So we present an optional solution to separate dissemination of routing topology and traffic engineering information and other types of application information into multiple flooding process within the zero instance of the ISIS protocol. So I think this is just a set of lightweight extension to the ISIS update process. So I think this draft why we try to clarify it's important to propose because it's private and optional solution to isolate the effect of flooding and the processing of non-routing information on the routing stability. And this solution can minimize the complexity of implementation and the cost of agencies' maintenance due to in less mechanism we share a common agencies and a single link state database. Next slide, please. So here we defined the multiple flooding instance, and we also specified a new TLV carries the identifier in each of layers, link states PDUs, and sequence number PDUs. Yeah. Next slide. So here we give an simple example here to clarify the update process operation. We have defined extension in last draft, and you can find that an example shows in the table means that each label link states PDU carries flooding information and belong to a specified MFI. And yes, in each MFI, update parameters can be customized depending on the requirements on the flooding rate of different information. Next page. Thank you. So here is the consideration of the interoperability. And I think the next page is more important. I think the time is limited. And here we have a conclusion and a comparison with the multi instance. And we think we have more discussing in the mailing list between these two drafts. But we need to point out the multi-flooding instance is a different solution to isolate the non-routing information flooding, and we can see that it's different in the aspects of the number of protocol instances, the number of adjacency, and the number of the link state database. So we think this is a lightweight solution to describe the complexity of the implement, and also minimize the cost of the adjacency and maintenance. Yeah.
All right, Ellie, I think we hit the mark. So we're the last presentation, so I don't mind leaving it open for a little bit, but just know that.
Yeah, that's all. I think it's the last page. Yeah.
So I have
more comments and questions are welcome, and we will refine the draft. Yeah. Thank you.
Thank you.
I guess I'm the first one on the queue. This is AC, speaking as a working group member. I was just going to say, you said it's easier to implement. You've implemented this? It decreases the complexity of implementation. Have you implemented it? Yali?
Yeah. Hi, AC. Sorry, I missed on your question. Sorry.
Your slide said that this reduces the complexity of the implementation. Have you implemented this?
This is analysis result between the multi-instance and the multi-flooding instance. This is not the conclusion of the implementation result.
Yeah, I mean, I would disagree with that. That it's easier to implement if you're actually going to get separation, but that can be discussed on the list.
Okay, well, we ran only a little.
Yes, go ahead.
Oh, AC, do you have something to add? I was just going to wrap the meeting.
Yeah, you can wrap it. I want to make a point that this is probably the first LSR or ISIS meeting where Les has not made a comment. So.
Okay then. Well, I think we had some interesting stuff come up. It's too bad we don't have, the lounge or whatever to go to. I guess there's Gather. But in any case, I'll see you guys on the list. Well, we'll see you on the list, and probably not in San Francisco, but virtually. Thanks.
Thanks, everyone.
Thank you.